Welcome friends, in this one, let's take a look at finding the antiderivative of x plus 4 over x squared plus x. So first what I'm going to do is on the left side, I'm going to write this as x plus 4. And then on the bottom, I'm going to factor an x out. So it's going to be x on the outside and then x plus 1. And then on the right hand side, to do a partial fraction decomposition, you have to put something like the following. A over x, that is the first factor on the bottom, plus, and then here it's going to be b over x plus 1. So what you want to do now is just multiply every single term in this equation by the bottom of the left hand side. So it's basically like this times like this, x times x plus 1. And then you grab the next one here, so a over x, and you multiply that by x times x plus 1. And then you grab the next one here, b over x plus 1, and then you multiply this by x times x plus 1. What you do now is just cross off on the left hand side. So specifically, you see how like this x here will cross off with this x plus 1 will cross off with x plus 1. And that's what it looks like right now, which means on the left hand side, all that is left over is x plus 4. But on the right hand side, it's going to work like the following, right? This x here will cross off with that x, which means over here, what you're going to end up with in this position is just a times x plus 1. For the next part over here, let me move this back over. This x plus 1 will cross off with this x plus 1 over here, which means all that's going to be left over is b times x. So here you're going to do for that reason plus bx this way. Now you need to get the values of a and b. So you can do this as follows. First, set x equal to 0. So when you do that, you will have 0 plus 4 is equal to a times 0 plus 1 plus b times 0 this way. And I'm choosing 0, you see, because it makes the b go away. So then continuing with this, on the left-hand side is going to be 4, and the right-hand side is going to be basically a. For the next one, I'm going to set x equal to -1. Why am I doing that? Because -1 plus +1 here will give me a value of 0. It will make the a go away. So for that reason, I will have -1 plus 4 is equal to a times -1 plus 1, and then plus b times -1 this way. Continuing here, I'm going to have the following. -1 plus 4 is +3 on the left-hand side. -1 plus 4, +3. Over here, -1 plus 1 will be 0, so it's going to be a times 0 plus b times -1, which is the same as just -b. Continuing here, a times 0 will go away, so that will leave you with 3 equaling -b. Then you divide both sides by -1, so it's going to tell you that b therefore is equal to -3. So what I can do now is I can take my integral and I can write it differently instead. Take a look. I can write it now as follows. I can write, instead of writing x plus 4 over x squared plus x, I can write this instead as a over x. The value of a from up here is 4. So I'm going to put 4 over x. And then minus b, so the value of b here is 3 over x plus 1 dx this way. Then you can distribute the integral operator to each piece individually here. So when I do that, it's going to be basically like this. I'm going to put the 4 on the outside, leaving the first integrand just as 1 over x dx. Minus, pull the 3 on the outside. And then here you're going to integrate following basically. 1 over x plus 1 dx. Then you can anti-differentiate each one, so it's going to be 4 times the ln. You can use the ln rule for 1 over x. So 4 times ln of the absolute value of x. You need the absolute value bars because x could be negative, and ln cannot take negative values. The next one is going to be minus 3. And because we have only x plus 1 in the bottom of the expression, this is again going to be ln of the absolute value of just x plus 1, and then you add the c at the very end. And then this is the answer. Thanks so much for watching. Please leave a like and subscribe. I'll see you in another video.